Hi everyone, welcome to the lesson on econometrics. Today we'll be talking about issues in using OLS with time series data. Before we start, let me introduce myself. My name is Hedayat and I will be your presenter for today. For background, I graduated from National University of Singapore with a bachelor's degree in economics. Currently, I am an analyst for the analytics team at Kantar Singapore. Previously, I was a marketing intern for a local sports analytics startup called Matrix. This is an overview of what will be covered later on. By the end of the lesson, we will be able to understand what issues time series data pose when we try to apply OLS. First, we will try to understand on what do we mean when we say time series is stationary and weakly dependent, and why we need those properties. Second, we will see the difference between asymptotic properties and properties under classical assumption. For reference, we will be using Woolrich Introductory Econometrics, Chapter 11. First, we define a time series to be stationary when their probability distribution are stable over time. We want them to be stationary because time series are correlated since they usually depend on previous time period. For example, stock property of a price today will depend on yesterday prices, and yesterday prices will depend on the day before, and so on. Stationarity allows us to apply the law of large number and central limit theorem, which is needed for OLS. This is to prevent any distortion caused by time, so we can understand the relationship between variables from different time periods. We have two types of stationarity: weak or covariant stationarity and strict stationarity. Weak stationarity is when the process of xt, which is a time series data, has a constant mean and variance throughout all time period. The second moment has to be finite and its covariances does not depend on h. H stands for horizon, the length of time into the future. A process is strictly stationary when their joint distribution is the same as their counterpart with t plus h. Take note that strict stationarity has the same properties as weak stationarity, but with the added requirement for joint distribution. What is not stationary is when they do not have any of the requirements previously mentioned. For example, the trend component of this time period is trending upwards. This gives us an indication that our time series mean is increasing over time. Another indication is when our mean has a subscript t, right here. This also means that our time series is not constant as it varies over time. We say a time series to be weakly dependent when the correlation between xt and xt plus h approaches zero when h gets large. This also means that this time series is asymptotically uncorrelated. This allows us to assume that the time series are of random sampling. Because we have replaced the assumption of random sampling, we are able to apply OLS, as law of large number and central limit theorem can still hold. The motivation for this subtopic is that classical linear model assumptions can be restrictive for time series application when our sample size is small. One remedy is to use asymptotic properties when we have a large sample size, which is enough to make statistical inference or analysis. First, our process has to follow a linear structure along with stationary and weak dependence as previously discussed. When our model is linear, it means that there is a linear relationship between the independent variable x and the dependent variable y. In this case, if xt1 increased by 1 unit, yt increased by beta 1. The second asymptotic property is that independent variables must not be perfectly collinear. For example, xt1 should not be derived from other variables like x2 or x3 or xt1 equal to xt2 plus a constant. The third property is the zero conditional mean, where xt must be uncorrelated with the error term in the same time period. However, for properties under classical assumption, uncorrelation is required for all time periods. This is the most important difference between the asymptotic properties and properties under classical assumption, which makes classical assumption more restrictive. Take note of the capital T versus XT. The fourth property is homoscedasticity, where the variance of the error term given XT is constant in the same time period. In contrast, property under classical assumption requires the same variances for all time periods. The fifth and the last property is no serial correlation between errors in different time periods. However, classical assumptions require no serial correlation for all time periods. To summarize today's lesson, the main idea is how do we deal with time series when we want to apply OLS to them. We need to ensure that our data is stationary and weakly dependent, so we can ensure that the law a large number and central limit theorem hold, which is important for OLS. Asymptotic properties allow us to implement OLS to our time series data, so it can be practical for applications as long as sample size is large. That is all. Thank you.